everyone. Whenever we come across the word symmetry, what comes to our mind? A butterfly, right? Or maybe a kaleidoscope. But do you think the symmetry just ends with butterfly or kaleidoscope? Not at all. In physics, symmetry plays a major role in certain laws and theorems. Sounds interesting, right? Let's get started.
Consider this card. I am going to apply some changes to this card by rotating it by an angle of 180 degree. Now, can you find any difference between the original state of the card and this rotated state of the card? Obviously, you will not be able to find any difference.
But why is it so? It is because of symmetric property of the card. Symmetry is a change that causes no change. I think it's confusing. Let me make it more clear. Symmetry can be explained as a transformation that leaves a system fundamentally unchanged after the transformation has been performed. Yes, it leaves the card unchanged after it has been rotated by the angle of 180 degree.
Now, consider a ball which is rolling in a straight line. It will continue to roll with the same speed, in the same direction, and with the same energy forever. In this case, the momentum of this ball at any point on its path will remain the same. This ball is now said to be a translationally symmetric, and in this symmetry, the momentum of the ball is conserved. Let us see another example. We all know that satellites revolve around our Earth in circular orbits. The gravitational force between the satellite and the Earth will remain the same at any point on the circular orbit. This is now said to be a rotationally symmetric, and in the symmetry, the angular momentum is conserved. Generally, a system is doing a work with some energy. After few hours, the same system doing the same work with no change in the energy. In this case, the time will continuously change, but the energy will not change. Thus, the system is considered to be time translational symmetry, and in the symmetry, the energy is conserved. In all these cases, that is, in these three symmetric cases, we continuously come across a word conserved. In each symmetric case, a particular quantity is conserved. Of course, we would have come across many conservation laws in physics. Where do these laws came from? It was answered by a great mathematician, Emmy Noether. In her theorem, she stated that these conservation laws emerged from the symmetries of nature. To be very clear about Noether's theorem, for every continuous symmetry in the universe, there exists a conserved quantity. Yes, this is where these all conservation laws came from. It's amazing, right?
Finally, we conclude by saying that symmetry naturally existing in this universe contributes the fundamental law of conservation in physics. As we said earlier, symmetry not only ends with the butterfly or in kaleidoscope, rather it contributes the laws and theorem in physics. Always question and always wonder is physics.